superposition principle says that the force on a test charge particle would be the vector sum of all those individual charges, right? So that was the thing that we understood. That was the superposition principle, right? Yeah,
Yes.
that. This was the superposition principle, and we saw that the net force is just the sum of the vector sum of all the individual. So now let us try to understand that, because now we already know the vectors. So now let us try to understand with a question. So let's say that you are given the q plus q. This is minus 4q. This is minus q, and this is okay. So this is minus 4q plus 4q, and this is minus 4q. So these are the charges placed at the corners of a square. So this has a length A, and A. Okay. And you have 4 charges. And then you want to calculate, the force on the test charge which is kept at the center. So you want to calculate what is the force at this charge. So some charge plus q is kept at here, and you want to calculate, let's say this is O point. So what is F net at O point? Okay, this is what you want to calculate. And that would be how much? C and D. So what would be F net at O point? What would be F net? How many contribution would be there for this center charge? How many contribution of forces would be there?
So 4.
Right. So there would be a Coulomb interaction between this one, between this one, between this one, between this one. So you have 4 individual charges, individual interaction. So if I write in terms of the superposition, so that would be FA plus FB plus FC plus FD, right? So I can do this problem in 2 different ways, right? So one idea would be that, let's say, what is the contribution from this Q and minus Q and T and here. So this is a negative charge, right? And you are calculating the force at this point. So at this point, due to this charge, the force would be attractive or repulsive. What would be the force?
At which point?
At this O point, you are calculating the force on O due to B, right? Let me write it as AO, BO, CO, DU. We are calculating at O point, right? At O point, we are calculating. So first, let us write the contribution of FAO. How much is that, right? So FAO is, this is plus Q. And due to this one, FAO would be in which direction? That would be attractive. So this charge would be attracted or repelled by this A1. What would happen? Yes.
So it will negate each other because one is attracting others.
It will negate. You see,
No,
this is,
sir. Can you explain?
yeah.
I
So
didn't
I'm,
understand.
yeah. So you have this plus Q test charge, right? You have this plus Q test charge and this A charge. So this A point, this plus Q charge is kept. So this will apply some force to this charge, right?
Yes, sir.
So we are calculating the force at this point due to A, which is plus Q charge. This is plus, this is plus. So force on this point would be repulsive or attractive. What would be that? Due to A point,
Sir, repulsive.
repulsive. So it will repel in this direction, right? It will not attract, it will repel. So this is FA. Clear?
Yes, sir.
Okay, so now we have got this FAO. And what about this due to this B1? So would be attractive or repulsive? What would be that?
Sir, attractive.
Attractive. So it will attract in this direction, right? So this is B. Okay, correct.
Sir.
And then you have this 4Q charge. So this 4Q charge will attract this charge or repel this charge. What will happen?
Sir, the fourth charge.
This one.
So it will attract,
It will attract towards its side.
repel.
So you have said attract and repel. What is the confirm? Which answer we should lock?
I'm not sure, sir. I
Yeah.
didn't.
So yeah. So this is plus charge, right? This is
Yes,
plus.
sir.
This is plus. So it will attract or repel
Yeah.
each other.
Positive order. It will repel.
Repel. So it will repel this charge, right? This charge will try to repel this charge in this direction, right?
Yes, sir.
Clear? Is that clear? Is that clear?
Yes, sir.
Okay, so now we have got this one. Now let us find out the contribution from this one, right? So contribution from this one. And this is negative charge, this is positive charge. So this will attract or repel. This charge will attract this charge or repel this charge. What will happen?
It will repel.
This is positive, this is negative.
Okay, so it will attract. It will attract.
So where will this force due to C will go? In this direction or in opposite direction? Where will that force go? Yes.
So in that direction.
In what direction? A direction or C direction? What is the
So I think
force?
so. I think so in A direction. Just
So in A direction, this charge will move in this direction due to this one, which means that this charge is repelling this one, right? Is this
yes,
is this getting repelled or attractive? What is happening to this charge?
so C is negative and A is positive, right?
So,
So
so what will happen? Attracted or
since I think so, from A it will be repelled, and
yeah.
from C it will be get attracted.
So that will go in this direction, right? Force will
Yes, sir.
so due to this minus Q, that will be so this is FC, right? Due to this minus Q.
Yes,
Is that
sir.
clear? So you
Yes, sir.
yeah. So you see that F FBO and FDO are in same direction, right?
Hmm.
So they will add up. They will add up. They are in same direction, so they will add up. So the magnitudes of if I calculate magnitudes of FBO, let's say that this is one F1. So that would be FBO, and let me write only the magnitude. That would be FBO plus FD because they are in the same direction. Is this part clear?
Yes, sir.
And let's say F2, this one. So FCO and FAO magnitude is at, right? That,
Yes.
so what would be the magnitude of FBO? FBO is K and Q1, Q2 divided by R square. So what is the magnitude of Q1? FBO. FBO, right?
Yes, sir.
So, and whenever we write the magnitude, so we don't write the charges, right? We don't write the charge. So that is K. Q1 is 4Q, and this one is Q divided by the distance between O and B. So this is a square, and this would be this total length. This is A, this is A. So this would be root 2A, right?
Yes, sir.
So total length is root 2A. So this length would be half of that OB, right? OB square. So OB is half of BD, which is root 2A by 2. That is OB, right?
Yes, sir.
Similarly, OA would be same, root 2A by 2. OC would be same, root 2A by 2. And OD would be same, because that is a square. So all these lengths are same. Okay. So this is how much? This is 4 KQ square by OB square. Right. Now, what is FD? FDO is again K4Q Q divided by OD square, which is 4KQ square by OB square, because the OD is equal to, right? Similarly, what is FOC? So how much would be FOC? Can you tell me? What is the magnitude of FOC?
Sir. K.
Yes. And we're talking about the forces due to O and C. So what are the charges at O and C? They are
So
Q,
4Q.
Q, right? Q and Q.
How, sir?
So charges on C is Q,
Okay. And
and charges on O is Q.
so for what about oh, okay, so in FTO it's plus 4. I didn't notice the plus 4, sir.
Yeah, yeah. So D is 4 and B is 4, right?
Yes.
And remember why we are not writing the sign of the charges, because we have incorporated the direction, right? We have already incorporated the influence of the negative polarity. So that is why we are not writing the minus 4Q and minus 2. Yeah. So divided by OC square, which is KQ square divided by OB square. Similarly, what would be OA? That would be again KQQ divided by OA square, which is KQ square by OA square. Now we see that F1 that is in the same direction. So let us calculate F1. F1 would be FBO plus FDO. So 4KQ square by OB square, 4KQ square by OB square. So that is 8KQ square by OB square. And F2 is how much? OC and OA. So KQ square by OB square plus KQ square by OB square. So you have 2KQ square by OB square. So what have you found out? You have found out that there are two forces which are perpendicular to each other, right? They are perpendicular to each other because the diagonals of a square perpendicularly bisect each other, right? They are at 90, right? So this angle is 90. This is F1, this is F. Is that clear to you?
Yes, sir.
So you have F1 vector and F2 vector. So what would be the resultant of these two vectors? What would be that?
Sir, 90 degree.
Yeah, that is, I'm asking the resultant of two vectors. Let's say, let's say you have a vector which is, this is A, this is B, this is theta. So what is the resultant magnitude? What is that?
B vector plus A vector is. Yes,
Ma- Magnitude is A square plus B square plus 2AB cos theta. That is the resultant magnitude, right?
yes, sir.
So then what would be F net? F net would be F1 square plus F2 square plus 2 F1 F2 cos of theta. What is the angle between F1 and F90? So this becomes a 0 because cos 90 is 0. So this is cancelled. So F net would be F1 square plus F2 square. So that would be the result. So now let us find out what would be the magnitude. So this would be F1 is how much? F1 is 8KQ square by 4B square. 8KQ square by 4B square and then whole square plus what is in here? So 2KQ square by 2B square. These are F1 and F2. Is that clear?
Yes, sir.
So then if we write it in proper terms, so this is 36K square and Q4 divided by OB power 4 plus this is 4K square Q4 divided by OB. So we can take K square common and we can also take a 4 common. We can take K square common. We can take Q square common. Or let's say Q4 common. and then we can take OB4 common. These are common, and what do we get in here? What we will get in here? If I take 4k square q4 OB4 common, so what will be there? What will be in here? What would be the first term? Yes, what would be the first term? I have taken k square common. I have taken q4 common. I have taken OB4 common. And from 36, I have taken 4 common. So what is remaining in the first term? Yes, Arsalam. What is remaining in there?
Sir, 9?
9, right? And in
No,
here
no,
we
sir.
have,
Oh, sorry, sir. I was saying, but my mic was turned off.
okay, yeah.
I didn't realize. I thought you were saying like I was wrong or something.
No. So I didn't hear because your mic was off. Yeah. Yes. Sorry about that. Yeah. So
No, sir.
I
It's fine.
told,
It's my fault.
yeah.
I didn't
So,
notice also.
yeah. So, okay. So, and in here one would be there, right? So then we take these things outside of the root. So that would be 2. This would be k. This would be q square. This would be ob square and root of 10. This is the answer. Then we already know that what is, yeah, OB we already, that is root 2 by 2a. So we put that value. So we will get how much that we will get 2q square 10. This is 2a square by 4. So this part cancelled out. So we will get 4kq square root 10 by a square. So that would be the net magnitude of these roots, right? And
Yeah.
direction would be in where? Where would be the direction? So direction would be in this way, right? Because if we use the parallelograms law, so we make the parallelogram in here. If we join this, so that would be the result, right? So this was the question. Any doubt in this question? There were numerous things to calculate, but did you understand this part? Did you understand?
Yes, sir.
Yeah. So all we have to do is that we have to write all the forces, and finally we saw that these two, whenever we have, let's say, we have two vectors. One is, let's say, 2i, and then we have this another vector 5i. So what would be the resultant? 7i, right? So similarly,
Yes.
in this part, we had two vectors which were in the same direction. So that is why we added the magnitude of these two vectors. We added the magnitude of these two vectors. But now we cannot add these magnitudes because they are in perpendicular direction. So then we calculated F net. And F net was just the vector sum of these two. So that is what we did in this. So you please note down this question, and then, yeah, then we will talk about the next one. Always remember that we follow superposition principle in case of the Coulomb. Okay. Yeah, please note down this part, and then, and whenever you want me to scroll down the screen, please tell.
Yes, sir.
Yeah, whenever you have noted it down, please tell.
Yes, I scrolled down.
Just remember what were the forces, right? So we had we had these kind of forces, right? So at this point, two forces were in this direction, F BO and F DO, and then two forces were in this direction, F OC and F O, right? And then we just calculate. So these we told them as F1 and these we told them as F2. That is what we have done, right? So in here F1 is, did I write F1? Yeah. So FBO, FD. Whenever you want me to scroll down the screen, please.
Yes.
Yeah, whenever you have noted it down, please. Yeah.
Yes, I just a bit more.
Okay. Good,
Almost. Yes, sir, scroll down.
Whenever you have completed, please.
Yes, sir, almost done. Yes, sir, done.
Yeah. Okay, so the next topic and important topic is equilibrium. What is an you have already learned in your 11th standard that yeah. So you have already learned that if you have let's say this is a point, right? And some external forces are acting on this particle. So let's say if one force is acting in this way, one force is acting in this way, one force, other force. So all these forces are acting, right? Now let me draw in this way. So we have this one, and these are two figures. Let's say this is F1 and F2, F F3, F4, F5, and F6. Similarly, you have this F1, F2, and F. So if this point is at equilibrium, then it will be said that the total forces acting on this point or this particle is cancelling out each other, right? So all these forces are cancelling out each other. So if I calculate F net, so that would be F1 plus F2 plus F3, F4, F5, F6, and they are cancelling out each other, which means that that is 0. So if I have the total force which are cancelling out, then the object or the particle is said to be in equilibrium, right? That is the definition of. So that is what we know about the equilibrium condition, right? Is that clear to you?
Yes, sir.
So similarly, in the case of electrostatic force, again, let's say you have a charged particle, and some forces are acting in every direction. So other charged particles are there. Some are attracting, some are repelling. Then if the total force on that charge is zero, then that charge would be called at equilibrium, right? So there are there are two kinds of equilibrium in case of electrostats, right? So what are those? One is that a point is at equilibrium. And the second thing is that system is at equilibrium. So there are two kinds of equilibrium for the case of the electricity, right? Let's say you have, let's say first understand about the first thing, which is one point. So a point is at equilibrium. Okay. So let's say we have two charges, right? Let's say this is plus q, and we have another charge which is, let's say, plus 50, right? And we are trying to find out a point between these, so distance between these charges are n. So we are trying to find a point between these two charges so that this point is at equilibrium. So let's say we have another charge q at this point, and this point is only at equilibrium. So this point is at equilibrium, right? I'm not thinking about the equilibrium of this point, equilibrium of this charge. I'm only thinking about the equilibrium at this point. So if this point, let's say this is A, this is B, and this is C. So only C is at equilibrium. That case would be said that only a point is at equilibrium. So only C is at equilibrium, which means that, which implies that what would be the force on this point? What would be the force on this point?
Mm,
Zero,
0.
right? So F net at C would be 0, right? So F net at C, that would be 0. So then this C point is at equilibrium. So F net is 0 at this point. Is that clear? Is that clear, Arpita?
Yes, sir.
So how many forces are acting on this point? How many forces? how many forces are acting on this
So
point?
around three.
Three. Where is the third one? I can only
So
see. I
so
cannot
say
find
two
it.
two.
Two, right? So only due to this A and due to this B. So now we have to figure out what is the force on C due to A and due to B. So let us find out due to A charge. This is positive, this is positive. So at this point, force would be repulsive or attractive to this point, this charge, due to this charge, right? So
Yes, sir.
force would be repulsive or attractive.
Sir, attractive.
This is positive, this is positive.
No, never mind. It will be repulsive.
Repulsive. So where would be FA, right or left? This is repelling. So where would be the force, right or left?
Sir, right.
Right. So this is my FA. Right. Good.
Yes, sir.
And now we have to figure out the force due to B on C. So what kind of force would be that? Attractive or repulsive?
Sir, neither. Because
Yes, repulsive.
yes, sir.
And where would that be force? Where would be the force? Left or right? Due to B.
Sir, left. No. Yeah, yeah. Left.
Yeah, please confirm. Please lock one answer, right? Because at
Yes, sir. Left.
D, yeah, this charge would be repelled by this charge, right? So left. So this is FB. Now you see that this FA is acting in the right hand side, FB is acting in the FB side. So if this point is at equilibrium, which means that FA equals to FB. Is that correct?
Yes, sir.
If both the forces are, yeah, if both the forces are equal and they are in opposite direction, so they will cancel each other out, right? So let's say that some 3I hat force is acting in the right hand side. So to cancel this one, the other force would be minus 3I hat, right?
Yes,
Right?
sir.
So these forces would be equal in magnitude. So let's say you have FA and you have this FB. So this FA should be equal to FB so that they cancel each other out, right? 3 and 3, right? So this has
Hmm.
magnitude 3 and this has magnitude 3. This has direction. Magnitude is 3. Direction is minus I hat. This has magnitude 3 and direction is I hat. So that is why their magnitude is same, but their direction is opposite. So that is why they are cancelling each other out. Similarly, the magnitude FB and FA should be same and direction is opposite we already. So then they will cancel out. So if F net is 0 at C, then FA should be equal to F, right? So let's say
Yes,
we
sir.
have to figure out what is the distance. Yeah, we have to figure out what is the distance that we have to place this charge so that this point is at equilibrium. So let's say this is X. What would be this length? What would be this distance? Total is L. This is X. What would be this distance?
Hmm.
Yes. From here to here, this is X. From here to here, this is L. So from here to here, what would be the distance?
Sir, L minus X. Sorry. I keep
Yeah.
on forgetting the mic isn't
Oh,
open
so
all the
you
time.
oh yeah, yeah. So
No,
that is
sir. I
why
keep
I
on
thought that we are.
forgetting. I keep on forgetting that the mic isn't open. So I say and you don't say anything. So I think I'm
Yeah, yeah, yeah.
wrong.
So yeah, that happens. Yeah. So technical features, right? So don't worry about those. Yeah.
I don't know. Sometimes when I'm pressing space, the mic isn't turning on. I didn't notice. I don't notice right at times when I'm speaking.
Yeah.
But
So
when I'm
maybe
pressing space, yeah, I don't know why, sir.
so shortcut key for unmuting the mic is space. Maybe sometimes space button is not working that well. Maybe that's
Yes,
the
sir.
reason. Okay, so now we have to calculate what is the Coulomb force due to this charge. So how much would that be? K. And what is the other charges? Fa would be how much? Coulomb force. Coulomb force. Just remember what is Coulomb force. Q1, Q2, R. So Coulomb force is K Q1 Q2 by R square. We are trying to find out the force between A and C. So these are the forces. Separation we know, charges we know. What would be the force? Fa. Again, are you? Uh,
Yeah,
again,
okay,
I should
sir.
go.
Fa is equal to then KQ Q1 Q2 R
What is
square.
Q1? What is Q1? This point is A. This is C. So what is Q1
Hmm.
in here? That is Q. What is Q2? That is Q. Right.
Hmm.
So Q and Q. So K Q Q divided by what is the separation between A and C?
R.
A and C, A and C. Well,
Oh,
just Mir, Assalamu alaikum, Mir. You're late, very late. Yeah, so okay, so don't worry, we only start. Yeah, so we only started this topic. We have just started this equilibrium portion. So we are saying that let's say some point is at equilibrium, which means that all the forces acting on that point they cancel each other out. So sum of all the forces would be zero. That is called the equilibrium condition. And in electrostats, we have two cases of equilibrium. One is that only a point is at equilibrium, and then the second thing is that the system is at equilibrium. So we are understanding about the point is at equilibrium. So we have two charges, plus Q and plus 4Q, and we are placing a third charge Q so that this point is at equilibrium. This charge is at equilibrium. So we are only talking about one point is at equilibrium. So what we are doing, we are placing this charge at some x distance and we are calculating Fa and Fb and that should be equal so that this is at equilibrium. So that is what we are doing. Okay, so separation is how much? Between A and C, not R, A and C from here to here. What is the separation?
X.
X square, right? So similarly, you tell me, Arsalan, what would be C between C and B? What is the Coulomb force?
Okay, sir. KQ 4 plus 4Q.
Yeah, we don't write this sign. Whenever we are
Oh, okay,
calculating, because we have already incorporated the direction. When we have incorporated the directions, we don't talk about the signs.
okay, sir. Divide by L minus X the whole square.
Yeah. This is what we have to do. K is cancelled, Q is cancelled, Q is cancelled. So we have 1 by x square 4 by L minus x square. So we take this one in the left hand side, this one in the right hand side. So both these are perfect squares. So we taking square root in both these sides. So then this would be L minus x and this is 2x. So this would be L equals to 3x. So x would be L by. So which means that place we have to place this charge at L by 3 distance from this plus Q charge. So equilibrium is equilibrium is at L by 3 distance from plus Q charge. That is where the charge would be at. Is that clear? Mir and Asran, is that clear?
Yes, sir.
Okay, so you guys please note it down, and if Mir you have any doubt, please ask. That. So now we have done just only that a point is at equilibrium. Yeah, whenever you guys want me to scroll down the screen, you guys please. Yeah, whenever you guys want me to scroll down, please.
This is scroll down.
And whenever you guys have noted it down, please. Got disconnected. Whenever you guys have noted it down, please.
Yes, sir. Done.
Done. Okay, so now let us understand that. Let us understand about the second kind of equilibrium. So second kind of equilibrium is system is at equilibrium. Right? So when a system is at equilibrium, then what happens? Let's say you have three charges, right? Three charges are placed, and a whole system is at equilibrium, which means that all the forces at every point. So F net is zero at this point, F net is zero at this point, and F net is zero at this point. So because what is the system? System is containing these three charges, right? The system constitutes of these three charges. And when the system is at equilibrium, which means that all these individual charges are at. In the previous case, when one point was at equilibrium, so we didn't think about the other two charges, right? But when the system is at equilibrium, so every charge is at equilibrium. So this says that every charge is at equilibrium. Okay, so this is what we mean by system is at equilibrium. So let us try to do one question, and then this would be easy. So question is that same question, two charges are placed at L distance apart with values plus q and plus 4, right? So question is that what would be the nature, position, and magnitude of the third charge so that whole system is at equilibrium. Right, so we have to find out nature, position, magnitude of the third charge so that whole system is at equilibrium. So what is the question? We have this plus q charge, we have this plus 4q charge, and we are putting some charge. Let's say this is at L distance apart. So we are putting a charge, right? And let's say some q charge, and let me write it as q, right? Some q charge, so that whole system is at equilibrium, right? And we have to find out nature. Nature meaning that whether it is positive or a negative charge that we have to put. So this whole system is equilibrium, which means that F net in here is 0, F net in here is 0, F net in here is 0. Okay. So let us see the example that let us suppose that we are taking a positive charge in here. Okay. So we are first trying to find out the nature. To find out the nature, let us suppose let us suppose Q is positive. Okay. So we have discharge, discharge, discharge. Capital Q, this is plus 4. And this system is at equilibrium, right? So first, let us find out what is the force on this charge. So force on this charge, right? This is 1 due to C. So this direction. Due to C, the force would be in this direction. Is that clear? Yes. Is this clear, Arsalan and Mir?
Yes, sir.
Now we know that this whole system is at equilibrium. So what would be the F net in air? So at A point, there would be two contributions, one from B, other from C. So what would be the direction of the force due to B, right or left? What would be the direction? Arsalan and B, you guys tell. What would be the direction of force at A due to B?
So at 8 will go at the opposite direction because, pollution.
Yeah, right or left? Right or left? Repulsion would be
So
left. Yes.
right.
So this is plus Q. This so it will be repel, right? Repelling is in this direction. At this point, this is repel, right? This
Mm-hmm.
will repel this charge. So left, right? And now due
Yes.
to C, where would be the due to this charge C? Due to this charge C, what would be the direction at this point? Right or left?
So left because it's repelling.
Left.
I'm not sure.
So this is repelling, right? Plus 4QQ.
Yes, sir.
So again repelling this charge, right? Is that clear? Is this clear, Mir?
Yes, sir.
Yeah. And now let us calculate the force on this C point due to B and A charge. So what would be the direction, guys? Due to A, what would be the direction? Right or left? We are calculating the force on C point due to A. This charge will attract this charge or repel this charge. What will happen? Yes, guys, tell me.
So
These are plus Q, 4Q, plus, plus.
yes, sir.
They
So
will
they'll repel, right?
repel. So this will be repelled or attracted, right or left?
Left.
This is attracted towards this one. This is attracting.
Okay, sir.
Left,
So right.
left meaning that this charge is attracting this one, but it is not. So this would be
Right.
FB.
Yeah.
And what about this FB1, right or left? Due to FB, due to plus Q, what would be the direction of this? Small. Yeah, what would be the direction, left or right? Yes, guys, due to this V charge plus Q charge, there would be repulsive force or attractive force. What would be the force?
Be a repulsive.
Repulsive, so left direction, right direction, right?
Yes, sir.
So you guys see that at B point, this is balancing. Is this point is being balanced at A point? Is this balancing? This is acting in this direction. This is acting in this direction. So are these forces balancing each other out? Are these
Yes,
forces
sir.
balancing? They are balancing. How they are balancing?
Sir, because they're
Balancing
both
means that
going
if
in.
one is acting in this direction and the same
So,
direction, both are repelling this one.
yes, sir. Both
Both are
are.
repelling this one because
Yes, sir. So, it's not balancing each
both
other
are,
then.
yeah, both are repelling, which means that it is not being balanced, right? So which means that here F net is not zero, right? Same
Yes,
case in
sir.
here. F net is not zero, which means that charge cannot be positive, right? This case invalid, right? If
Yes, sir.
the system is at equilibrium, then this case is invalid. Clear, guys? Now
Yes,
let
sir.
us now let us take the example of negative charge. So we have so these are straight lines plus q, and we are considering a minus q charge, right? Okay. So let us figure out at this point. At this point, this charge will attract or repel. This charge will attract this charge or repel this charge. Yes. This is positive charge. This is negative charge. So this positive charge will attract this negative charge, right?
Yes, sir.
So it will move in this way due to A, right?
Hmm.
Similarly, we have this positive 4q charge. This is negative. So this positive will attract this one.
Yes, sir.
So in here, those two forces are balanced, right? Now let us reach at this point. So at this point, this is negative. So this will attract towards its direction, right? Clear?
Yes.
And this plus 4q charge will do what? That will attract or repel.
So it will also attract.
This is positive, this is positive.
Oh, yes, that will repel. Repel then, sir.
So that will repel. So you see that this point and this point, they are balancing. So F net is,
Zero.
now let us come to this point. So at this point, there are two charges which are applying the force, minus q and this one. So this minus q will try to pull this charge because this is negative.
Yes, sir. And the plus Q will repel, so it will balance out, right?
This will repel. So this is F. Again, we see that this is balancing. So now you guys know that which charge, what should be the nature of the charge we should put so that this system is at equilibrium. So what should be the nature? So
So
the,
it's at E.
the
So it's at
charge
E.
should be negative so that whole system is at equilibrium. Here, so nature is negative. Nature
Yes, sir.
is negative. Here, everyone.
Yes, sir.
Now, let us remember this diagram. So I will just directly write the diagram. Second thing we have to find out the position, right? So we already know. Let's say this is x. This is L minus x. This is plus q. This is plus 4q. This is minus q. Right. So we already know that this is A, B, and C. So at B, this this is FA. This is FC. So at B, FA is equal to FC, which means that what is FA? FA is KQ by x square. FC is KQ whole cube. K whole cube divided by L minus x square. So we have already solved this part, right? And we have got x equals to L by 3. So I'm not writing that again. So position is L by 3 distance away from plus q charge. Right? Is that clear? Now the
Yes,
third
sir.
part is that we have to calculate the magnitude. So how much is the value of q? What is the value of q? So again we will use the same diagram. So A plus q minus q plus 4q b c x L minus x L, right? These are the things. So we will remember what we have written at A point. At A point, we have written that this is FB, this is FC. So at A point, FB equal to FC. Is that correct, Arsalam?
Yes, sir.
So you tell me how much is FB. You tell me how much is it. We are
So,
calculating so we are calculating the force on this point due to this charge. So these are the two charges. Q minus Q separation is X. So what is the force? Coulomb's law.
uh, K Q K A
What
uh,
is the charge? What are the charges?
plus Q and minus Q. So
Q and Q, right?
yes, sir. Divided by x square.
Yeah, so we don't write it. So x square. Now, without any confusion, please tell me what is FC. We are calculating the force due to C charge at this point. So what is FC? Let me just write this one for the clearance. What is FC? Coulomb's law, K Q1 Q2 by R square, right? So what is Q1? What is Q2? What is separation?
Sir,
Yes.
KQ1, Q2 bias.
So we are calculating the
Sir,
force
I
on
didn't understand your question. So we're calculating what?
what is FC? What is FC? What is the
Oh,
force on this point due to this C charge? What is FC? This is the equivalent diagram. This is A, this is C. We are calculating force on A due to C.
okay, sir. So it's K Q 4Q Q into 4Q divided by E square.
L square, right? L, this is L.
Oh, sorry.
This is L, this. Good, so now Q will cancel, K will cancel, and Q is 4Q and X square by L square. And we already know the value of this X. X was how much? L by 3, right? So X square would be L square by 9. So 4Q and L square by L square into 9. This one cancels and we get 4Q by 9. And we know that polarity is negative. So this is minus 4Q by 9. Nature is negative. Did you understand this part? Did you
Yes, sir.
understand? So magnitude is 4Q by 9. So these are the three portions that we needed to find out. So please note down this portion. Please note down and then stop it. So, oh, Mead, you are already here. Yes, Mead. So did you understand this part? I thought you got disconnected. Mead, is that clear?
Yes, sir.
So please, you guys note it down, and if you guys have any doubts, please ask. Yeah, whenever you guys want me to scroll down, please write it.
Next, let's go.
So system is at that is how affinity is 0, affinity is 0.
Yes, sir, scroll down.
Yeah.
So scroll down.
Yeah.
So
Yeah. Whenever you guys have completed noting it down, please do.
Sir, I'm done.
Done. Meera, have you also noted?